Okay, so we'll continue. This second part of the video will talk about a little bit more details about the confusion matrix. So we kind of went over in the previous part the idea behind how we evaluate, right, the predictive ability of our logistic regression by splitting the data into two, right? Use the training data to fit our model, and then use that model to predict to estimate the probabilities, right, for the test data, and then use a threshold to decide, right, how we're going to classify our test data based on the estimated probability. And so we kind of went over briefly, right, the confusion matrix as a way to summarize, right, the true positives, true negatives, false positives, false negatives, and we'll go through the confusion matrix in a little bit more detail in this set of slides I'm going to go over right now. So this is how it might look like. So over here, right, in the columns, right, this is basically saying that the true value of the response is no, the true value of the response is yes, and the columns, I write it as the classification, right, says no, and this column represents the classification says yes. Now, truth be told, right, some people might switch the rows and columns, so just be careful as you read the table. Right, because not everyone will put the truth in the rows, and they might reorder it a little bit. Right, so true negatives, right, represent the negatives, right, that are true. So that means the negatives given by our classification, right, is truly also a no, right? So that's the true negatives. False positives basically says that the model will classify the person as being positive, but that person is truly a no. Right, and then false negative, right, will be the model classifies this person as a no, but the person is truly a yes. And the true positive means, right, that the model classifies this person as a yes, and that person is truly a yes. So a few terms that we have over here, right, overall error rate basically are the false positives and the false negatives divided by the sample size. So and the sample size, basically the sum of these four cells over here. Right? So we add all these values, you get the sample size. So that's the overall error rate. Basically, notationally, I like to think of these in mathematical terms. So it's basically saying that your value of your predicted y is not the same as the true value of the y. False positive rate, or type 1 error rate, the symbol for this is basically saying that if this person is classified as 1 by the model, but the person is truly a 0. Now, that's how mathematically this is denoted. Based on the table, this is basically false positives divided by true negatives plus false positives. So it's basically saying that, right, out of all those who are truly 0, so that's why the denominator has true negatives plus false positives, what proportion of these tests are classified as yes? So those who are classified yes are the false positives. False negative rate is kind of almost the other way around, where the model classifies this person as a no, but it's truly a yes. So it's kind of the other way around. So this will be false negatives over the total number of positives, false negatives plus true positives, right? So if you take a look at the table, it's basically saying out of all those who are truly yes, so that's why the denominator is false negative plus true positive, what proportion of them are false negative? So that's why it's Fn in the numerator. Some of the terms you might have heard, sensitivity, it's basically probability that the person is classified as yes when the person is truly yes. So sensitivity is basically 1 minus the false negative rate, right? So that's how we could write this, and this could be written as TP over false negative plus true positives, right? So again, this is saying out of all those that are truly yes, what proportion of these are correct? So the denominator again is Fn plus TP, and the correct ones are the TP. Specificity is also probability of being correctly classified as a no, and this is just 1 minus the false positive rate, and this is going to be true negative over true negative plus false positive, right? So again, out of all those that are truly no, right, so that's why the denominator is Tn plus Fp, what proportion of them are truly negative. So these are just some terms, kind of up to you which one you prefer. Personally, I like the mathematical symbols here because there are less terms to remember. To me, the mathematical terms are very intuitive. So let's go over a few examples. So this is the Titanic example, right, when we have a threshold of 0.5. So what is the overall error rate, right? So the overall error rate over here would be the values in the off diagonals, right? Because the off diagonals represents the number of mistakes you have, right? So the overall error rate will be 30 over 44 divided by the sample size, right? Which is just the addition of all the cells. And if you kind of simplify this will be 74 over 354. False positive rate, that's going to be probability that the person is classified as yes, but it's truly no. Right, so truly no means that out of these people, right, so that's why the denominator is going to be right, 180 plus 30, right, what proportion of them were classified as yes, which is 30, right, so that's why the numerator is going to be 30. So this value here would be 30 out of 210. False negative rate, probability, right, that the person was classified as 0, given that the person is truly a 1. So this means that out of all these people who are truly a 1, so out of the 44 plus 100, what proportion of them were classified as 0, which would be 44, right? So this value would be 44 over 44 plus 100. And if you work this out, this will be 44 over 144. Sensitivity, right, is just probability of that it's classified as 1 when it's truly 1. And we know this is the complement of the false negative rate, so you could have just done 100 over 44, right? But right, so it's 100 over 144 because out of all those that were 1, right? So that's 144 in the denominator. How many of them were correctly classified as 1? That's 100. Specificity, y hat equals 0 given y equals 0, right? So out of all those who are truly 0, which is 210. How many of them were correctly classified as 0? That's 180, right? So that's how we can find out all these values over here. So over here we have another table. This is the same data set, but now I changed the threshold instead of 0.5 to 0.7. So I'm going to pause here a little bit to give you some time to work these out. I'm not going to explain it, so I'm going to pause here now, and then I'll just give you the answer. Okay, so hopefully you pause the video and kind of work through some of these. These were the answers that I got, so I'm not going to go over these individually, but if you got them, if you worked out the fractions, again, I didn't simplify the fractions, right? False positive rate, 9 out of 210. False negative rate, 98 out of 144. And then sensitivity would be 46 out of 144, and specificity would be 201 over 210. Right, so one thing I mentioned, right, if you raise the threshold, you will lower the false positive rate, but the false negative rate will go up, right? I kind of mentioned that in the previous video.